Pure Integration has created a fully integrated true private cloud offering based on HP technologies that can provide live demonstrations of integrated HP cloud and ITSM software. This infrastructure offering allows customers to see a fully fleshed out environment that simulates what a private cloud looks like in a real production environment. Rather than just a few point tools linked together, this environment integrates change and incident management, asset management, and monitoring with a full stack HP cloud. More than slides, being able to show real services being built with real change control will engage customers and show them the whole picture, not just a piece of the puzzle. It paints the vision of where customers can go and helps educate them on how to get there. We provide customer access to the environment, configured for them specifically, that will allow remote POCs and the experience of a full cloud stack. If you have a customer thinking about cloud, if they want a way to automate their internal environment to deploy servers and systems, then watch this demo video and call Pure Integration to help. Let us help you keep the HP cloud and automation conversation going with your customers. The content in Pure Integration's private cloud offering has been designed to be ported to customers' environments, allowing for faster integration times and production-ready services. It introduces customers to solutions outside of the cloud and automation stack and will help them see what is truly possible rather than a marketing promise in a slide. Our private cloud offering fully integrates HP technologies and other industry technologies such as CSA, Operation Orchestration, OpenStack, server automation with ITSM tools such as Service Manager, Asset Manager, and Universal Discovery. The advantage of this lab is that it provides an accurate view of what a cloud system looks like in a production environment. Private and hybrid cloud are built to allow for quick and easy self-service in requesting services. In our environment, customers will log into the CSA Marketplace portal and request their service. Depending on the customer, they would see different service offerings depending on their role and permissions. CSA, of course, offers very granular organization and user permissions. Here, the customer can request a simple IaaS service, such as Windows Server, or something more sophisticated, such as a multi-tier WordPress environment that builds a complex app spanning 2 OSs. In addition, depending on the customer's needs, the customer could request building services out on public clouds, such as AWS or Azure. When a service is built, OpenStack provisions the basic OS, and a tool called Server Automation is responsible for pushing out the necessary applications, whether something simple, such as an antivirus software, or something complex, such as a database or JBoss server. Server Automation will continue to manage the servers after they are built, ensuring that they stay patched and compliant with the security policies such as FISMA, PCI, SOX, or HIPAA. As well as providing a very easy portal to allow customers to request services, the Cloud Lab is able to rapidly provision systems, significantly increasing time to value. Behind the scenes, cloud administrators are able to define new services. They can create simple IaaS services quickly and more complex multi-tiered applications. These can be shared out amongst everyone or just specific organizations. Here is where monitoring tools can be attached to services. In addition, change management can be integrated into the services, ensuring that the right people approve the right services. In a cloud environment, servers are provisioned at the time the user places an order in CSA. The setup of monitoring must also happen automatically as a part of the provisioning process to ensure that the servers are monitored before they start to be used. The automation also has to ensure appropriate monitors are attached depending on the type of service deployed. For example, a production server may have different monitoring requirements than development, and a web server will be monitored differently than a database server. As the service is built in the Pure Integration Cloud demo environment, HP SiteScope is set up to monitor metrics such as CPU utilization, memory usage, free disk space, and swap space utilization. As you can see for this WordPress web server that was deployed, specific monitors are also set up for critical application processes, such as the Apache HTTPD service. This ensures that application health checks are put in place, even with no administrator interactions during deployment. It is also important to note that monitoring does not have to be done with SiteScope if a customer already has existing tools in place. If they're a BMC Patrol customer or even use an open source tool like Nagios, these can be integrated into the deployment workflows to ensure that the setup of monitoring is something that is done automatically as service is deployed. When a customer looks at automation and efficiencies in their request and change process, then the integrations from CSA to Service Manager PI have built are the answer. Take, for instance, approving and tracking a change ticket for a service subscription. With the CSA to SM change ticket and approval integrations pureIntegration has built, we have eliminated the need for review based on certain profiles. Different profiles in different services can be automatically assigned to different types of approval, which can be auto-approved or multi-level approval. The WordPress service here is connected to a single approval level where the requester's manager needs to approve the ticket in order to launch the service. Approvals that are more sophisticated can be built in requiring multiple authorities to approve a request. Since tickets are automatically generated by CSA, it provides accurate change logs and does not require an individual to make manual tickets that can contain mistakes or inaccurate information. As services are built via an OO integration, they are automatically discovered by Universal Discovery. UD will look at services built, discover the size of the instances built, like CPU count, memory and storage, and determine all software that has been deployed to them. This information gets stored in the UCMDB, providing a trusted source of truth. If changes are made to the services or additional software is added, this will automatically be detected and the UCMDB records are updated. When services end, UD will automatically update UCMDB to show that the services have been terminated. UCMDB also integrates with Service Manager, allowing the change service the ability to pull accurate CIs or configuration items to be populated into Service Manager tickets. HPE's Asset Manager is integrated into our lab to UCMDB via the UCMDB to AM push adapter. This information can provide accurate counts of server hardware statistics, but also other information such as running software, processes, services which are vital to any organization who require a full picture of their IT environment. IT executives can utilize this information for more leveraged purchasing to respond to software audits for software license compliance. This functionality has the ability to notify the organization when they are running low or out of licenses, or low on disk space, to name a few reconciliation points. When services are canceled and the UCMDB is updated, that is reflected in the Asset Manager, showing that licenses have been freed up, giving management the ability to see a true count of what is being used and what is still available. Now that we have talked about deployment of infrastructure and applications in private or hybrid cloud environments using CSA, and seen those deployed services set up for monitoring, patching, and asset tracking all automatically, it's important to note that there are many other use cases for automation with operations orchestration in a customer environment. Some customers may use OO to assist with onboarding of staff, where OO can provision user accounts in appropriate systems given the new user's job role and function. Another common use of automation, and one that is very applicable in an environment such as cloud, is called closed-loop incident processing, or CLIP. CLIP allows for an automated remediation of issues, complete with change management and notification. It's probably easiest to see an example of how this is used and how this concept can be applied in an almost unlimited capacity within a customer environment. In this demonstration, we've shown how multi-tiered web applications such as WordPress can be deployed using the HP suite of a cloud and automation tools. Now let's say that the deployed WordPress site is actively being used. We'd probably want to know if a critical service, such as the Apache web service, has gone down, since that means the website would be unavailable. In fact, we might even want our automation tools to automatically restart the service after letting us know that it's down, and logging an incident in our service management tool. So let's see how that happens. Here, we'll manually stop the Apache HTTPD service on our web server in order to simulate a problem. We can see that the site scope monitoring that was set up automatically when the service was deployed has fired an alert showing that the service is unavailable. Sitescope now automatically calls an operations orchestration flow to remediate the issue. OO now takes action by first notifying the appropriate team that the website is down. It then logs an incident ticket in HP Service Manager, and this is important as it creates a traceable log of the actions that were taken. When we say closed-loop incident processing, this is what we mean. We're not just taking corrective actions automatically that no one is aware of, but instead ensuring that there is an audit trail of what was done. Now that an incident ticket is open, OO goes to work trying to restart the service. If the service was restarted successfully, email notification is sent back out that the issue has been remediated, and the incident ticket is closed with the appropriate detail noting successful resolution. If the service was not able to be restarted, OO updates the incident ticket with what has been done, then sends a notification so that the administrator can take further corrective action. As you can probably see, Clip has many use cases within a customer environment, and each customer application can drive its own automated remediation requirements. The important thing to remember is that this type of automation is all set up when a user initially deploys a service through CSA. No administrator action was required to set this up after the user ordered the service. Customers want to see what the HP tools really look like, not slides which hint at their capabilities. By showing full integrations, it allows customers to believe it can happen and think big. It builds confidence that the HP tools work in real-world environments and solve real problems, enabling customers to be faster and more adaptive in a changing world.